Today let us revise one topic from class 10th maths part 2, that is the trigonometry. So there are some points in the topic trigonometry and some examples based on that. So we have a trigonometric identity and the relation between the trigonometric ratios. So based on that there is one practice set 6.1. So we are going to solve some examples from that practice set. So let's start with the first question. If sin theta is equal to 7 by 25, then find the values of cos theta and tan theta. So we have to start with the given, that is we are given that sin theta is equal to 7 by 25, and by using that we have to find the value of cos theta and tan theta. So to find the value of cos theta we must know the relation between sin and cos. So there is one trigonometric identity which established the relation between sin theta and cos theta, and that is the first trigonometric identity, sin square theta plus cos square theta is equal to 1. So in this identity we have two variables, sin theta and cos theta, out of which the value of sin theta is given. So we have to just replace sin theta by 7 by 25. So in this trigonometric identity, sin theta is replaced by 7 by 25, and as sin square is there, we have to make a square of 7 by 25. So 7 by 25 bracket square, it is replaced with sin square theta plus cos square theta as it is, that is equal to 1. Now if we make a square of both of these two terms, 7 and 25, we get 7 square is 49 and 25 square is 625 plus cos square theta is equal to 1 as it is. Now we have to find the value of cos theta, as we can see here. So we have to transfer this 49 by 625 to the right hand side. So it will become minus 49 divided by 625. Now here we have to cross multiply, as the denominator of 1 is not given, so it must be 1. So if we cross multiply, we get 625 into 1, that's 625, minus 49 into 1, that's 49, divided by 625 into 1, that's 625. That is equal to cos square theta. So to the next step, cos square theta is equal to 625 minus 49, that's 576, divided by 625. But we want the value of cos theta, so we have to take a square root on both the sides, as we have got the value of cos square theta. So if we take square root on both the sides, we get square root of cos square, that's cos theta, and square root of 576, 24, divided by square root of 625 is 25. So this is the value of cos theta, that is cos theta is equal to 24 divided by 25. So we have got the answer of the first question, value of the cos theta. Now again we want the value of tan theta also. Now as of now we have value of sin theta, we have found the value of cos theta. So if we have sin theta and cos theta, by that we can find tan theta, as there is a relation between tan theta, sin theta and cos theta, and the relation is tan theta is equal to sin theta by cos theta. Now here we have both of these two values, sin theta and cos theta, so we have to just replace it. This sin theta is replaced by 7 by 25 divided by cos theta is replaced by 24 divided by 25. Now to simplify this, we will take 7 by 25 in the numerator as it is, and if we take 24 by 25 from the denominator to the numerator, we should take its reciprocal. So the reciprocal of 24 by 25 is 25 divided by 24, as we have taken it in the numerator. Now here in the numerator and denominator, 25 will get cancelled. So in the numerator we have 7 into 1, that's 7, divided by 24 into 1, that's 25. So this is the value of tan theta, that is 7 divided by 25, 7 divided by 24. So we have also got the answer of the second question, that is tan theta. So this is how we can get the values of some of the ratios if any one of the trigonometric ratio or the value of any one of the trigonometric ratio is given. So and here we have used the trigonometric identity. Sometimes we have to use the relation between some of the trigonometric ratios also. So let's have the next question. In the next question also, the value of one of the trigonometric ratios is given, that is if tan theta is equal to 3 by 4, find the values of sec theta and cos theta. So again we have to start with the given, tan theta is equal to 3 by 4. Now we want here the value of sec theta, so we must know the relation between tan and sec. which is there. That is the second trigonometric identity, and that identity is 1 plus tan square theta is equal to sec square theta. So here we have the value of tan theta, so we have to replace here tan theta by 3 by 4, so as to get 1 plus 3 by 4 bracket square is equal to sec square theta. Now we have to make a square of this, that is 1 plus 3 square is 9 divided by 4 square is 16, that is equal to sec square theta. Now again here also the denominator of 1 is not given, so it must be 1, and we have to now cross multiply. 16 into 1, that's 16, plus 9 into 1, that's 9, divided by 16 into 1, 16, that is equal to sec square theta. So on the left hand side in the numerator 16 plus 9, that's 25, divided by 16 is equal to sec square theta. We want the value of sec theta, so we should take square root on both the sides. So square root of 25 is 5 and square root of 16 is 4, that is equal to sec theta. So this is the value of sec theta, that is sec theta is equal to 5 divided by 4. We got the answer of the first question, sec theta. Now from that we have to find the value of cos theta. So as we observe, sec theta and cos theta are the reciprocals of each other. So if once we have the value of sec theta or cos theta, from that we can get the value of the other one. So we have to use the relation cos theta is equal to 1 divided by sec theta, as these two ratios are reciprocals. So here cos theta is equal to 1 divided by value of sec theta is 5 by 4. So replace sec theta by 5 by 4. Again, if we take 5 by 4 in the numerator, it should be its reciprocal, that is 1 as it is in the numerator, divided by, if we take 5 by 4 in the numerator, it would be 4 by 5. So 4 by 5 into 1, that's 4 by 5. So this is the value of cos theta, that is we have got the answer of the second question. So here to solve this question we have used the second trigonometric identity. Let's have another one. If cot theta is equal to 40 divided by 9, find the values of cosec theta and sin theta. So again we have cot theta is given 40 divided by 9. Now here we have to use the trigonometric identity which involves cot theta, and we know that there is the third trigonometric identity, that is 1 plus cot square theta is equal to cosec square theta. So we have to use that as we have to find the value of cosec theta, and in this trigonometric identity we have the value of cot theta. So we'll just replace this cot theta by 40 divided by 9, that square is equal to cosec square theta. So again 1 plus, we have to make a squares of both of these two terms. 40 square is 1600 divided by 9 square is 81, that is equal to cosec square theta. Again we have to cross multiply here to have 81 into 1, that's 81, plus 1600 into 1, that's 1600 divided by 81, that is equal to cosec square theta. So if we add the numerators, we get 1681 divided by 81 is equal to cosec square theta. Again we should take a square root so as to find the value of cosec theta. So by taking square root on both the sides, we have square root of 1681, it's 41, and the square root of 81 is 9, that is equal to square root of cosec square theta is cosec theta. So this is the value of cosec theta, that is cosec theta is equal to 41 divided by 9. So this is the answer of the first question, and from that we have to find the value of sin theta. So again it is similar to the previous one, that is cosec theta and sin theta are again reciprocals of each other. So we should have sin theta is equal to 1 divided by cosec theta. This is the relation which states the relation between sin and cosec, as these are reciprocals. We have value of cosec theta 41 divided by 9. So we have to replace here cosec theta by 41 divided by 9 in the denominator. If you take 41 divided by 9 in the numerator, it should be its reciprocal, that is 1 into reciprocal of 41 divided by 9, that is 9 divided by 41. So 1 into 9 divided by 41 is equal to 9 divided by 41. So this is the value of sin theta. So this is the answer of the second question. So these are some examples where we have used the three trigonometric identities and the relation between various trigonometric ratios. So this is how we can solve examples like this. Now let's have another question. So this is the another question which we have to for which we have to use the trigonometric identities, but uh, this example is different from the previous three examples as we have solved. In those examples, only one trigonometric ratio or the value of only one trigonometric ratio is given. Now here there are two trigonometric ratios, and it is given in the form of algebraic expression. So first of all, we should convert these if we can in the form of only one trigonometric ratio. Then only we can have the values of sec theta, cos theta, and sin theta. So let's start with this given expression: 5 into sec theta minus 12 into cosec theta is equal to 0. Now if we take minus 12 cosec theta to the right hand side, it will become plus 12 cosec theta. Now we know that sec is a reciprocal of cos. So if we take 5 in the numerator as it is, and sec is nothing but 1 divided by cos. In the same way, to the right hand side also, we have taken 12 in the numerator as it is, and instead of cosec theta, we have written here 1 divided by sin theta. So we'll get this expression: 5 divided by cos theta is equal to 12 divided by sin theta. Now this time we'll take sin theta to the left hand side, so it would be in the numerator, so as to have sin theta divided by cos theta, and we'll transfer 5 to the right hand side so as to have in the denominator, that is equal to 12 divided by 5. So sin theta divided by cos theta, we know the relation, that is tan theta is nothing but sin theta divided by cos theta. So we'll replace sin theta by cos theta by tan theta, that is equal to 12 by 5. Now this is the value we wanted, that is we have expressed this expression in the form of tan theta is equal to 12 divided by 5, and now by using this we can find the values of sec theta, cos theta, and sin theta. Now we have the value of tan theta, and first of all we should find the value of sec theta. So we have to use the second trigonometric identity, that is 1 plus tan square theta is equal to sec square theta. So this is the second trigonometric identity. So we'll replace here tan theta by 12 by 5, that square is equal to sec square theta. So 1 as it is plus 12 square is 144 divided by 25 is equal to sec square theta on the right hand side as it is. Again here also we have to cross multiply. So 25 into 1, that's 25, plus 144 into 1, that's 144, divided by 25 into 1, that's 25 in the denominator, is equal to sec square theta. Now if we add the numerators, we get 25 plus 144, that is 169, divided by 25 is equal to sec square theta. But we want the value of sec theta, so we should take square root on both the sides. So taking square root on both the sides, we get square root of 169, that's 13, divided by square root of 25 is 5, that is equal to square root of sec square theta is sec theta. So this is the value of sec theta, that is sec theta is equal to 13 divided by 5. This is the answer of the first question. Now once we have the value of sec theta, we can get the value of cos theta, as these are reciprocals of each other. So if sec theta is 13 by 5, cos theta must be its reciprocal, that is cos theta must be equal to reciprocal of 13 by 5 is 5 by 13. So cos theta is equal to 5 by 13. And finally we have to find the value of sin theta. Now we have the value of cos theta 5 by 13. So this is the first trigonometric identity, sin square theta plus cos square theta is equal to 1. Here we have to replace cos theta by 5 by 13. So sin square theta plus cos theta, instead of cos square theta we should write 5 by 13 square, that is equal to 1. So sin square theta plus 5 square is 25 divided by 13 square is 169 is equal to 1. We want the value of sin theta, so we should transfer 25 by 169 to the right hand side, it will become minus, that is sin square theta is equal to 1 minus 25 divided by 169. Now here also the denominator of 1 is not given, so it must be 1. Now we have to cross multiply as the denominators are different here. So 169 into 1, that's 169, minus 25 into 1, that's 25, divided by 169 into 1, that's 169, and that is equal to 169 minus 25, that is 144 divided by 169, that is equal to sine square theta on the left hand side as it is. We want the value of sine theta, so again we should take a square root on both the sides. So we get sine theta is equal to square root of 144, that's 12, divided by square root of 169, that's 13. So this is the value of third trigonometric ratio, that is sine theta is equal to 12 divided by 13. So this is another example where we are given the trigonometric ratio or the trigonometric ratios in the form of algebraic expression. So if such example is there, then we have to convert it in a single trigonometric ratio, because without that we cannot have the values that these are asked in this question. Okay. Now the next question. Now here we have to find the value of one algebraic expression which involves trigonometric ratios, and for that the value of tan theta is given. The question is, if tan theta is equal to 1, then find the value of sin theta plus cos theta divided by sec theta plus cosec theta. So we have to start with this one, tan theta is equal to 1. So this is given. Now if we have a trigonometric table where we have the values of 6 trigonometric ratios for various angles like 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. From that table we get the value of tan 45, that's 1. So here tan theta is given to be 1, but tan 45 is equal to 1. So if we compare these two equations, we get the value of theta as 45. So we have theta is equal to 45 degree. And once we have the measure of theta in this expression, we have to replace theta by 45 degree. So now consider the algebraic expression where we have to find the value of that. Sin theta plus cos theta divided by sec theta plus cosec theta. So sin theta, that means sin 45 degree, plus cos theta, that's cos 45 degree, divided by sec 45 plus cosec 45. Now again from that same trigonometric table we have to substitute values of these four trigonometric ratios. The value of sin 45 is 1 by root 2 and value of cos 45 is also 1 by root 2, divided by, in the denominator, as sec and cosec are the reciprocals of sin and cos, we have sec 45, that's root 2, plus cosec 45, that's also root 2. Then in the numerator we have the denominators same, so we can add numerators, that is 1 plus 1, that is 2 divided by root 2. As the denominator is same here, we have to write it once, and in the denominator we have root 2 plus root 2, that is 2 root 2. To the next step, 1 plus 1, that's 2 divided by root 2. So this is the numerator we have taken here as it is, and now we have to take 2 root 2 in the numerator. So to do that we have to take its reciprocal, that is 1 divided by 2 root 2. Now here in the numerator and denominator 2 will get cancelled, and now we have 1 in the numerator divided by root 2 into root 2. So we have here root 2 into root 2, that is 1 divided by root 2 square, and 1 divided by root 2 square, that means here square root and square will get cancelled each other's effects, so we have 2 in the denominator. So the value of this expression is 1 divided by 2. Okay. Now the next question is like prove that. We have to prove some algebraic relations or equations where the trigonometric ratios are involved. So this is the first question where we have to prove that sin square theta divided by cos theta plus cos theta is equal to sec theta. So as we have two sides over here, left hand side and the right hand side. So we have to prove that these two sides are equal. So we have to consider any of these two sides and we have to go on solving, or we have to make some adjustments to make the second side or to have the second side. So here if we consider the left hand side, as there are more terms than the right hand side, so we have to consider the left hand side. So consider the left hand side where Sin square theta divided by cos theta plus cos theta is equal to 1. So this example is straightforward. In the second term we have cos theta, so denominator is not given, so it must be 1. Here only we have to cross multiply, that is sin square theta into 1, that's sin square theta, plus cos theta into cos theta, that is cos square theta, divided by cos theta into 1, cos theta. Now here we have one replacement for this one, sin square theta plus cos square theta. So this is the first trigonometric identity, as a sin square theta plus cos square theta is equal to 1. So instead of this sin square theta plus cos square theta, we have replaced 1 divided by cos theta as it is. And 1 divided by cos theta, its reciprocal is there, and reciprocal of cos theta is sec theta. So we have started with the left hand side, and finally we have got here the sec theta, that is the right hand side. So the left hand side is equal to right hand side. So that is we wanted to prove, and hence we get the result that sin square theta divided by cos theta plus cos theta is equal to sec theta. So this is how we can solve this question. We have to consider any one of the sides, and we have to go on solving, or we have to use some trigonometric identities or the relations between trigonometric ratios to get the second side. So let's have the next question. Again, this is the question. We have to prove that cos square theta into bracket 1 plus tan square theta is equal to 1. So consider the left hand side again, because we cannot have the right hand side, because in the right hand side we have only 1. So consider left hand side, cos square theta into bracket 1 plus tan square theta. Now here we have to multiply by cos square theta for both of the terms in the bracket. So cos square theta into 1, that's cos square theta, and cos square theta into tan square theta. So that is the second term. So we have got these two terms. Now the first cos square theta as it is, plus cos square theta into, instead of this tan square theta, we can write sin square theta by cos square theta, as we have the relation between tan theta, sin theta and cos theta, that is tan theta is equal to sin theta divided by cos theta. That's why instead of tan square theta we can write sin square theta divided by cos square theta. Now both of these two are in the product form, so in the numerator and denominator cos square theta will get cancelled, so as to have the first cos square theta as it is, plus in the second term we have only sin square theta now, so sin square theta. So again cos square theta plus sin square theta, that is nothing but the sin square theta plus cos square theta, which is the first trigonometric identity, and value of which is 1. Sin square theta plus cos square theta is equal to 1, so we should replace here cos square theta plus sin square theta by 1, which is the right hand side. So we have started with the left hand side, and we have finally got the right hand side. Therefore LHS is equal to RHS, and hence the result cos square theta into bracket 1 plus tan square theta is equal to 1. Let's have the next question, where the square root is involved. So in this again we have to consider the left hand side, which is given to be under root 1 minus sin theta divided by 1 plus sin theta. Now to solve this question, that is we have started with the left hand side, and to get the right hand side we have to multiply both of its numerator and denominator by conjugate of the denominator, and the conjugate of denominator is 1 minus sin theta. So 1 minus sin theta divided by 1 plus sin theta as it is, into, we have to multiply both the numerator and denominator by 1 minus sin theta. So as we have done here, because the 1 minus sin theta is the conjugate of 1 plus sin theta. So if we multiply these two, 1 minus sin theta into 1 minus sin theta, that is 1 minus sin theta bracket square, and in the denominator we have 1 plus sin theta into 1 minus sin theta. Now this is in the form a plus b into a minus b, where the expansion formula is a square minus b square. That's why we have written in the denominator a square, that is the first term square. So first term is 1 here, 1 square, minus the second term is sin theta, so sin square theta. Now to the next step, we have in the numerator 1 minus sin theta bracket square as it is, instead of 1 square minus sin square theta, 1 square means 1 minus sine square theta. We have the replacement for this one, that is cos square theta. As we have the relation between sine theta and cos theta, that is sine square theta plus cos square theta is equal to 1. Now if we transfer sine square theta to the right hand side, we get cos square theta is equal to 1 minus sine square theta. So this is the substitution for 1 minus sine square theta. That is, instead of 1 minus sine square theta, we can write cos square theta as we have written here. Instead of 1 minus sine square theta, we have written cos square theta. Okay, now it's time to remove this square root sign. In the numerator, we have 1 minus sine theta bracket square. So this square root and square will get cancelled each other, so as to have only 1 minus sine theta in the numerator, divided by, in the denominator also, square and square root will get cancelled, so as to have cos theta. Now we'll split the denominator. 1 minus sine theta divided by cos theta, that is 1 divided by cos theta minus sine theta divided by cos theta. We have splitted the denominator for both of these two terms in the numerator. So 1 divided by cos theta, it's the reciprocal of cos theta, and we know the reciprocal of cos theta is sec theta. So instead of 1 divided by cos theta, we can write sec theta minus sin theta by cos theta, that's tan theta. So this is the right hand side, sec theta minus tan theta. So we have started with the left hand side and we have got the right hand side. So left hand side is equal to right hand side, and hence the result under root 1 minus sin theta divided by 1 plus sin theta is equal to sec theta minus tan theta. Okay, so this is the question. Now let me check out the network. Okay, that's okay, good. We'll continue now from the next question. So this is the next question. We have to show that sec theta minus cos theta into cot theta plus tan theta is equal to tan theta into sec theta. So again we have here the left hand side. We have to start with that. Left hand side is equal to sec theta minus cos theta into cot theta plus tan theta. Now here two binomials are there, so we have to make some adjustments. Instead of sec theta, we can write 1 by cos, as sec and cos are the reciprocals of each other. We'll take the second term in the first bracket as it is, cos theta, and in the second bracket we have the substitution of for both of these two terms, cot theta and tan theta. So instead of cot theta, we can write cos theta by sin theta plus tan theta. Instead of tan theta, we can write sin theta by cos theta. So we have, for the first bracket, we have to cross multiply. The denominator of cos theta is not given, so it must be 1. So 1 into 1, that's 1, minus cos theta into cos theta, that's cos square theta, divided by cos theta into 1, cos theta. So this is the expansion for the first bracket. In the same way, for the second bracket also, we have to cross multiply. Cos theta into cos theta, that's cos square theta, plus sin theta into sin theta, sin square theta, divided by sin theta into cos theta. Now we have again, as we have done the substitution for 1 minus cos square theta in the previous example, previous problem, there we have replaced 1 minus sin square theta by cos square theta. In the same way, we can replace 1 minus cos square theta by sin square theta, as there is a relation between sin and cos, that is the first trigonometric identity, sin square theta plus cos square theta is equal to 1. So if we transfer cos square theta to the right hand side, we will get 1 minus cos square theta, and that is equal to sin square theta. So that is, we have replaced here 1 minus cos square theta by sin square theta divided by cos theta in the denominator as it is, into, again here sin square theta plus cos square theta is there, so the substitution is 1 because of the first trigonometric identity, divided by sin theta into cos theta as it is. Now here in the numerator we have sin square theta and here in the denominator we have sine theta. So this sine theta and one of the sine theta in the numerator will get cancelled, so as to have sine theta into 1 or sine theta divided by cos theta into 1 divided by cos theta. So again here, instead of sine theta divided by cos theta, we have the substitution for that, that is the tan theta into 1 divided by cos, that is reciprocal of cos theta is sec theta. So this is we wanted to prove, tan theta into sec theta, which is the right hand side. So we have started with the left hand side and we have got the right hand side. So left hand side is equal to right hand side, and that is the result we wanted. Sec theta minus cos theta into cot theta plus tan theta is equal to tan theta into sec theta. Let's have the next question. Cot theta plus tan theta is equal to cosec theta into sec theta. This is very simple and straightforward. We have to start with the left hand side, that is equal to cot theta plus tan theta. So we have the substitution for both of these two terms. So instead of cot theta we can write cos divided by sine, plus instead of tan we can write sine divided by cos, as these are reciprocals of each other. Now addition of these two terms are there, so we have to cross multiply because the denominators are not same. So cos theta into cos theta, that's cos square theta, plus sin theta into sin theta, sin square theta, divided by sin theta into cos theta in the denominator. So again we have here in the numerator cos square theta plus sin square theta, that is sin square theta plus cos square theta, which is the first trigonometric identity and the value of which is 1. So instead of this one we can write 1 divided by sin theta into cos theta. Now let's split it out. 1 divided by sin theta into cos theta means 1 divided by sin theta into 1 divided by cos theta. So reciprocal of sin theta is cosec theta. 1 divided by sin theta, that's cosec theta, and 1 divided by cos theta, that's sec theta, which is the right hand side. So we have started with the left hand side, we have got the right hand side. So we get the result, that is cot theta plus tan theta is equal to cosec theta into sec theta. So this result is also true, and we have proved that. Now the next question. 1 divided by sec theta minus tan theta is equal to sec theta plus tan theta. So again we have to consider the left hand side. Generally we are going to consider left hand sides, but it is not necessary that all the time we have to consider the left hand side. Sometimes we have to consider the right hand side also, and from that we can get the left hand side. As of now we have studying, or we are taking the left hand side. So this is the left hand side given, 1 divided by sec theta minus tan theta. So we'll take this term as it is. To prove this, we have to multiply the numerator and denominator by the conjugate of the denominator, that is sec theta minus tan theta. Its conjugate is sec theta plus tan theta. So we have to multiply both of numerator and denominator, because we for any fraction we cannot just multiply the numerator or just numerator. If we have to multiply, we have to multiply both the numerator and denominator, so as to have the value of that ratio or the fraction remains to be same. So this is we are going to do. Now sec theta plus tan theta into 1, that is sec theta plus tan theta, divided by sec theta minus tan theta into sec theta plus tan theta. Now this is in the form a plus b into a minus b. So we have the expansion for a plus b into a minus b. So this is also one identity. The formula is a square minus b square. This is the expansion formula for a square minus b square is equal to a plus b into a minus b, or vice versa, a plus b into a minus b is equal to a square minus b square. So same here we have to apply, that is sec theta plus tan theta as it is in the numerator, divided by the expansion for this one is first term square minus second term square, that is first term is sec theta, that's square, minus second term is tan theta, that's square. Now here sec theta plus tan theta as it is in the numerator, divided by sec square theta minus tan square theta, that's 1, because we have the second trigonometric identity, that is 1 plus tan square theta is equal to sec square theta. Now if we transfer tan square theta to the right hand side, it would be 1 as it is in the left hand side, that is equal to sec square theta plus tan square theta, going to that side it would become minus tan square theta. So we have sec square theta minus tan square theta is equal to 1. So we have replaced here sec square theta minus tan square theta by 1. So that is equal to sec theta plus tan theta, that is the numerator itself, because in the denominator we have once. If we don't write that, okay, so this is the right hand side we get, sec theta plus tan theta. So this is the result we get again. 1 divided by sec theta minus tan theta is equal to sec theta plus tan theta. Okay, the next question is sec raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. Now we have to adjust something, that is the wrong question is there. It is not sec raised to 4 theta, but it is sine raised to 4 theta. So we have to do that correction. So consider the left hand side, which involves sine raised to 4 theta minus cos raised to 4 theta. We can write this sine raised to 4 theta as sine square theta bracket square minus cos square theta bracket square. Now we have here a square minus b square. So if we write that a square minus b square, we have the expansion formula, that is a plus b into a minus b. A square minus b square, that is equal to, in the first bracket we have the addition of both the terms, and in the second bracket we have the subtraction of both the terms. So same here we have applied. First term is sine square, second term is cos square. So in the first bracket we have added those two, and in the second bracket we have subtracted sine square minus cos square theta. So by the expansion formula we can write this. Now again we have the substitution for this one. Sine square theta plus cos square theta, that's 1 because of the first trigonometric identity, into sine square theta minus cos square theta. So again we have here sine square theta minus cos square theta into 1, that is sine square theta minus cos square theta. We have one substitution again here for sine square theta as 1 minus cos square theta. So 1 minus cos square theta minus cos square theta as it is, and we have done this substitution because of sine square theta plus cos square theta is equal to 1. If we take this cos square theta to the right hand side, it would be 1 minus cos square theta. So instead of sine square theta, we can write 1 minus cos square theta as we have written here. So 1 as it is minus cos square theta minus cos square theta, it is minus 2 cos square theta. So this is the right hand side. So we have started with the left hand side and we have got the right hand side. So left hand side is equal to right hand side. The next question is sec theta plus tan theta is equal to cos theta divided by 1 minus sin theta. So consider again the left hand side, that is sec theta plus tan theta. We have to substitute both of these two terms, sec theta and tan theta. As sec theta is the reciprocal of cos theta, instead of sec theta we can write 1 by cos theta plus there is a relation between tan theta, sin theta and cos theta, that is tan theta is equal to sin theta divided by cos theta. So we have replaced tan theta by sin divided by cos. Now here both the terms has the denominator same, so we can just add the numerators, that is 1 plus sin theta divided by cos theta. Now we have to find, or we have to show that this would be going to cos theta divided by 1 minus sin theta. So to do that we have to do one substitution, or we have to do some adjustment. In the numerator we have 1 plus sin theta, so we have to multiply both the numerator and the denominator by 1 minus sin theta. So as we have done here, so in the numerator we have 1 plus sin theta into 1 minus sin theta divided by, in the denominator we have cos theta into 1 minus sin theta. So again this is in the form a plus b into a minus b. So the expansion formula is a square minus b square, that is 1 square minus sin square, and the denominator as it is. So again we have 1 minus sin square, that is cos square, as there is a first trigonometric identity. So instead of 1 minus sin square theta, we can write cos square theta divided by cos theta into bracket 1 minus sin theta. Now in the numerator we have cos square and in the denominator we have cos theta. So this cos theta, and in the numerator or cos theta, 1 cos theta from the numerator will get cancelled. So as to have in the numerator cos theta divided by 1 minus sin theta as it is, and this is the right hand side. So we have again started from the left hand side and we have got the right hand side. So we get the result, sec theta plus tan theta is equal to cos theta divided by 1 minus sin theta. Okay. Let's have the next question. So this is very interesting question. If tan theta plus 1 by tan theta is equal to 2, then show that tan square theta plus 1 by tan square theta is equal to 2. But we may wonder that as tan theta plus 1 by tan theta is equal to 2, how can it be possible that if we make a square and add these two, we get the same result? So that is we are going to prove in this question. That's very interesting. So we have to start with the given, that is tan theta plus 1 by tan theta is equal to 2. We have to make square, or we have to show that tan square theta plus cos 1 plus tan square theta is equal to 2. That means we have to square on both the sides. So we have to make a square of left hand side so as to have it in bracket, because without having a bracket, if we are going to square the left hand side, we get the wrong result. That's why we should take this in bracket, that is tan theta plus 1 by tan theta is equal to bracket square, that is equal to 2 square, that is the square of right hand side. Now here we have to use the expansion formula for a plus b bracket square, and that is equal to a square plus 2ab plus b square. So we have to use this expansion formula here. First term square plus 2 into product of these two terms plus second term square. So first term here is tan theta. So we have tan square theta plus 2 into first term, that is tan theta, into second term, that is 1 by tan theta, plus second term square, and second term is 1 by tan theta. Its square is 1 by tan square theta, because the square of 1 is 1 itself. That is equal to square of 2 on the right hand side, that's 4. And as we have used here this expansion formula. Now for the second term, tan theta in the numerator and denominator will get cancelled. So as to have tan square theta plus 2 plus 1 by tan square theta is equal to 4. We want here the value of tan square theta plus 1 by tan square theta. So we'll remove this 2 on the right hand side. So if we remove this to the right hand side, it will become minus. So tan square theta plus 1 by tan square theta is equal to 4 minus 2, and 4 minus 2, that's 2. So this is the result we get, that is tan square theta plus 1 plus, that is tan square theta plus 1 by tan square theta is also 2. So this is interesting question, that is value of tan theta plus 1 by tan theta is 2. In the same way, if we make a squares and if we add these two, tan square theta plus 1 by tan square theta, it would be again 2. Okay. Now the next question is tan theta divided by 1 plus tan square, tan a divided by 1 plus tan square a bracket square plus cot a divided by 1 plus cot square a bracket square is equal to sin a into cos a. Now here, instead of having the left hand side or the right hand side, we have to use the another method. That is, we have to consider the left hand side, tan theta, tan a divided by 1 plus tan square a bracket square plus cot a divided by 1 plus cot square a bracket square. Now instead of 1 plus tan square a, we can write sec square a, because we have the second trigonometric identity, that is 1 plus tan square theta is equal to sec square theta. In the same way, we have the third trigonometric identity, 1 plus cot square a. Instead of 1 plus cot square a, we can write cosec square a, because of this third trigonometric identity, that is 1 plus cot square theta is equal to cosec square theta. Okay, now tan a as it is divided by sec square a bracket square, that means we can write here sec raised to 4a plus cot a as it is divided by cosec square a bracket square, that means cosec raised to 4a. Now instead of tan a, we can write sin a divided by cos a, as there is a relation between tan, sin and cos. In the same way, in the denominator, we have the reciprocal of sec raised to 4a, that is 1 by cos raised to 4a. In the same way, for the second term also, instead of cot a, we can write cos a divided by sin a divided by, instead of cosec raised to 4a, its reciprocal, we can write 1 divided by sin raised to 4a. Okay, now we have to take this both the terms in the numerator, so we have to take its reciprocal, that is sin a divided by cos a as it is into reciprocal of 1 by cos raised to 4a is just cos raised to 4a, plus for the second term also cos a divided by sin a as it is into reciprocal of 1 by sin raised to 4a, that is sin raised to 4a. Now here in the denominator cos a and 1 from cos raised to 4a will get cancelled. So instead of cos raised to 4a we would have cos cube a. In the same way here also sin a and 1 sin a from this will cancel, so we have sin cube a. So we have sin a into cos cube a plus cos a into sin cube a. Now from both of these two terms we can take sin a into cos a common. So sin a into cos a we would have in the bracket, as sin a is taken common, 1 cos a from cos cube is also taken common. So in bracket we should have cos square. In the same way here also from sin cube 1 sin is taken common. So in bracket we have sin square. So sin square theta plus cos square theta is 1. So we have replaced here cos square a plus sin square a by 1. That is into sin a into cos a as it is. So we have here sin a into cos a into 1. That is sin a into cos a, which is the right hand side. So this is the result we get. And let's have the last question. Sec raised to 4a into bracket 1 minus sin raised to 4a minus 2 tan square a is equal to 1. Now we have to use the next method. Again we have to consider the left hand side, which involves sec raised to 4a into bracket 1 minus sin square a minus 2 tan square a. So instead of sin square a we should write here sin raised to 4. That's mistake here. So this is the left hand side. Instead of 1 sec raised to 4a we can replace it by 1 divided by cos raised to 4a into, we have the expansion formula for this one. This is in the form 1 raised to 4 minus sin raised to 4, that is a square minus b square. So for this one we have the substitution a plus b into a minus b. So a means 1 square, that is 1 minus sin square into another bracket 1 plus sin square minus 2 into, instead of tan square a we can write sin square a divided by cos square a. So 1 divided by cos raised to 4 as it is, 1 minus sin square we have the substitution, that is cos square because of the first trigonometric identity, 1 plus sin square a as it is into minus 2 into sin square a divided by cos square a. So here cos square and in the denominator cos raised to 4a is there. So cos square from the denominator will get cancelled. So 1 plus sin square a in the numerator divided by cos square in the denominator minus 2 into sin square, that is 2 sin square a divided by cos square a. The denominators are same, so we can write it once, and in the numerator we have 1 plus sin square a minus 2 sin square a. So in the numerator we have 1 as it is, sin square a minus 2 sin square a, that's minus sin square a divided by cos square a. So 1 minus sin square a, again we have the substitution 1 minus sin square a, that is cos square. So cos square a divided by cos square a. So cos square in the numerator and denominator will get cancelled. So as to have 1 divided by 1, that's 1, which is the right hand side. Okay, now the last question. So to prove this one, we have to use the different method. Instead of having the left hand side or right hand side, we have to use one concept from theorem on equal ratios. So first of all, we start with this second trigonometric identity, 1 plus tan square theta is equal to sec square theta. So if we transfer 1 to the right hand side, it will be tan square theta is equal to sec square theta minus 1. So we can write it as sec square theta minus 1 square. So we can use the expansion formula sec theta plus 1 into sec theta minus 1. Now tan square means tan theta into tan theta. So we have done one adjustment here. That is equal to the right hand side as it is sec theta plus 1 into sec theta minus 1. Now out of these two brackets, we transfer one bracket to the left hand side. So we take tan theta in the numerator, and if we take here sec theta minus 1 on this side, we get it in the denominator, that is tan theta divided by sec theta minus 1, that is equal to here we have remained plus theta. Okay, some correction is there. Sec theta plus 1 divided by 1 tan theta, another tan theta, we have to take it on the right hand side, so it would be in the denominator. So divided by tan theta. Now these two ratios are equal, Now there is a theorem. Suppose A divided by B is equal to C divided by D. These two ratios are equal. Then each of the ratio must be equal to, we have studied this in the ninth standard, that is each ratio would be equal to A plus C divided by B plus D. That means if we add the first terms and the second terms, and if we get another ratio, that would be equal to each of these ratios, that is A divided by B is equal to C divided by D is equal to this one. So same we have to apply here. Tan theta divided by sec theta minus 1 is equal to sec theta plus 1 divided by tan theta is equal to, just add the numerators, this tan theta plus sec theta plus 1 divided by sec theta minus 1 plus tan theta. So that is equal to, we have to prove that the first ratio tan theta divided by sec theta minus 1, that is equal to, this would be tan theta plus sec theta plus 1, we have to make some adjustment correction here, divided by, if we rearrange these terms, we get tan theta plus sec theta minus 1, and that is we wanted to prove. So in this way also we have to prove some questions. So these are some examples from the practice set 6.1 from the topic trigonometry from class 10th. So that's it for now. We'll end this live session. Will be there another live session with another topic. Okay, that's okay. So we'll end this session here. Thanks for watching.